Welcome to today's class on first come, first served, FCFS, scheduling and operating systems. We'll dive into how FCFS works, its key characteristics, advantages, disadvantages, and practical example. First come, first served, FCFS, is a simple, non-preemptive scheduling algorithm used in operating systems. Processes are executed in the order they arrive. Similar to a queue, the first process is completed before the next begins. FCFS is easy to implement and ensures fairness since no process is skipped. However, it can cause the convoy effect, where slower processes delay others, leading to inefficiencies. FCFS is suitable for batch systems, but not ideal for interactive or time-sharing systems due to poor response time. The first come, first served, FCFS, scheduling algorithm has several key characteristics. Non-preemptive, once a process starts, it runs to completion without interruptions. Queue-based, processes are executed in the order of their arrival. Fairness, every process gets served without starvation, ensuring fairness in action. Convoy effect, slow processes can delay others, reducing overall efficiency. Simple implementation, it uses a straightforward queue structure, making it easy to implement. Poor for time sharing, not suitable for interactive systems due to long waiting and response times. These characteristics make FCFS simple but inefficient for modern multitasking environments. First come, first served, FCFS, scheduling and operating systems works as follows. Process queue. Processes are placed in a queue based on arrival time. Execution order. The process at the front of the queue is selected for execution first. Non-preemptive execution. Once a process starts, it runs to completion with interruptions. Next process execution. After the current process finishes, the next process in the queue is executed. While simple to implement and fair, FCFS may cause the convoy effect, where slow processes delay others. This makes it inefficient for interactive or real-time systems, as response times can be long. FCFS is batch processing with minimal variability in process execution times. The first come, first served, FCFS, scheduling algorithm offers several advantages. Simplicity. FCFS is easy to understand and implement, using a simple queue structure to manage processes. Fairness. Every process is executed in the order of arrival, ensuring no process is skipped or starved. No starvation. Since all processes are served in turn, there's no risk of indefinite waiting. Predictable behavior. Execution order is straightforward and easy to predict, making it easier to plan workloads. Low overhead. The system spends minimal resources on scheduling decisions since processes are executed sequentially. However, its fairness and simplicity are counterbalanced by inefficiencies, especially in interactive systems. Despite this, FCFS is still suitable for batch processing and scenarios with uniform process lengths. The first come, first served, FCFS, scheduling algorithm has several disadvantages. Convoy effect. Long processes can block shorter ones, causing delays and inefficiency. Poor response time. In interactive systems, user requests may experience significant delays, reducing responsiveness. No prioritization. FCFS does not account for process priority or urgency, leading to potential delays for critical tasks. Inefficient for time sharing. FCFS is not suitable for modern, multi-user time sharing systems due to long waiting times. Burst time variability issues. Processes with highly variable burst times can disrupt system performance, especially when long processes arrive first. Inflexible. Once a process starts, it cannot be interrupted, limiting adaptability to dynamic workload changes. These limitations make FCFS inefficient for systems requiring high responsiveness or fairness in priority handling. Here's an example of how the first come, first served, FCFS, scheduling algorithm works. Given process P1, P2, P3, arrival time, P1 equals 0, P2 equals 1, P3 equals 2. Burst time, P1 is 5, P2 equals 3, P3 equals 8. Execution order. Since processes are executed in order of arrival, P1 arrives first at time 0 and runs for 5 units, 0, 5. P2 arrives at time 1 but must wait until P1 finishes. It runs from 5 to 8. P3 arrives at 2 and starts after P2, running from 8 to 16. Completion times. P1 completes at 5. P2 completes at 8. P3 completes at 16. Turnaround time. P1 5, 0 equals 5. P2, 8, 1 equals 7. P3, 16, equals 14. Waiting time, P1, 0. P2, 5, 1 equals 4. P3, 8, 2 equals 6. This example illustrates the fairness of FCFS, but also highlights its potential for high waiting times due to the convoy effect.